Good morning students. Today we'll perform a practical number 14, that is decade counter using IC 7490. We have studied the construction of counter. Counter is nothing but a series of flip-flop which is used to count the number of clock pulses. Now we have also seen the design of mod counter. The mod counter is specially designed to count the specific levels of counting, because suppose we want to count a 5 number of step 0 to 5, then we'll design a mod 5 counter, and design of that counter we have studied in a theory. In theory, if we are going to design a mod counter, we'll use a K-map design, and we'll design accordingly our mod counters. Now if you want to count 0 to 9 pulses, that is 0 to 9 pulses, if you want to count 0 to 9 pulses, then total 10 clock pulses you have to count. For that purpose we have designed a decade counter, but for decade counter IC 7490 is provided to you. So with the help of that IC we'll see the how to construct the mod 5 counter, and we'll test the functionality of mod 10 counter or mod decade counter using IC 7490. Now the circuit diagram of IC 7490 is provided with you. So according to this we will done the construction of IC 7490 as a decade counter on a breadboard. So we'll see the connections for this. This is our breadboard, and in blue socket we have connected IC 7490, which is 14-pin IC. As you know, we are not using total 20 connections. That's why upper 6 columns are empty. So we are not using that connections, and we are going to consider pin number 1 at P4 and pin number 7 at P10. Pin number 8 at P11 and pin number 14 at P17. So we'll do the connection accordingly. This is our IC 7490 decade IC 14-pin IC. Now we'll see the connection. First we'll make a ground for all these pins. As you can see on a screen, pin number 10, 2, 3 and 6 and 7 all are connected to ground. So first we'll do the connection for ground. So this is pin number 10. It is first connected to pin number 2. Then this short is connected to pin number 3. Then taking wire from pin number 3 and we are going to connect this at pin number 6. Again this 6 is connected to pin number 7. So we have shorted the connection, all connection, that is pin number 10, 2, 3, 6 and 7 we have shorted, and now we are going to connect all this connection to ground. Now pin number 12 is QA, that is first flip-flop output. Pin number 9 is second flip-flop output QB. Pin number 8 is third flip-flop output QC, and pin number 11 is fourth flip-flop IC QD. So we'll do the connection for output. This is pin number 12, which we are going to connect at output side, is nothing but QA, that means output of first flip-flop A. Then we'll make a connection for pin number 9, and it is connected to next pin into output section, which is considered as output of flip-flop B, that is QB. Now pin number 8 we have taken from, and it is connected to output section, and it is considered as a output of C flip-flop, that is QC. Then we'll connect a pin number 11. This is pin number 11, and it is connected in output 5, which is considered as the output of D flip-flop QD. So we have made a connection for 4 flip-flop output. Now we'll connect pin number 1, that is clock B, to QA. pin number 1 is connected to pin number 12. So we have given clock B to first flip-flop. Then pin number 14 is clock A. So we are taking a wire from pin number 14 and we are going to connect it to clock, that is negative going clock. We are going to apply it. Then pin number 5 is VCC. We are taking wire from pin number 5 and it is connected to plus 5 volt supply. So supply is given to our decade IC. In this way all the connections are we have done all the connections, but pin number 4 and pin number 13 is no connection, so we'll leave it as it is. Will not do any wire, will not connect any wire to it. Now we'll see the function. We'll apply a clock pulses and accordingly our counter will count the states from 00 to 1001. That means total 9 states our counter will count. That's why the counter is called as a decade counter. So we'll you can see the first first all outputs are 0. That means a 0 state is there. All outputs are 0, 0, 0, 0. Then we'll provide a clock pulse. So our clock will count first state, that is 0001. Then we'll press next clock. You can see now the status is 0010. Then next clock pulse you will get 0011. Next clock pulse you will get 0100. Next clock pulse you will get 0101, that is fifth state. Then next clock pulse 0110, sixth clock pulse. Then next clock pulse 0111, seventh pulse is counted. Then next clock pulse this is 8th clock pulse, and lastly you will get a 9th clock pulse. Likewise this counter has counted a 0 to 9 step, so this is called as a decade counter. In this IC as you can see, this is the block diagram of IC 7490. It is having a 4 flip-flop, so you will able to make a combination of mod 2 counter, mod 5 counter and mod 10 counter, that is decade counter. So using this IC you will be able to perform mod 2 counter, mod 5 counter and decade counter. That's why the clock for next 3 flip-flop is given separately, that is a clock B. So we have connected this clock B to next flip-flop to run this IC as a mod counter. Thank you.